Hi, my name is Alessandro F. Garcia. I'm Technical Marketing Manager at NGINX. And since it's the last talk on the second day of the conference, I know most of you guys were probably a little bit tired, they're just about ready to head home and rest. So I decided to take like a fun spin on my talk and take some inspiration on the Great British Baking Show. And instead of the Great British Baking Show, I'm gonna make the Great API Management Bake Off with some pastries included at the end for your entertainment. So the first step in the Great British Baking Show, of course, is the signature bake. In this case, the signature bake is NGINX. NGINX is a very good API gateway tool. It's fast and versatile. It has native support for JSON Web Tokens, many other security policies too. You can deploy it as a traditional or micro API gateway. You can deploy it in north, south, and east-west stacks. It has a very low footprint. But how does NGINX really stack against other competitors? That's where the second part comes in, the technical challenge. So start with Kong. Kong is one of the most famous API gateway tools out there. It's built on top of NGINX open source, amongst many other tools. It's built for multi-cloud and hybrid environments, optimized for microservices and distributed architectures, and it has a pretty good rep. So we did some performance testing, comparing NGINX versus Kong. You can see the results there on the screen. These tests were conducted on premises using the Kong open source platform, and we did it using bare metal. There was a 22-cores machine, 128 gigabytes of RAM, just run work for some time, and we recorded the API calls per second we got. The API calls per second using JOT, and the latency added to a single request, which is how much of a delay you add if you query either NGINX or Kong. As you can see in the results, NGINX was much faster on average than Kong, using JOT or on its own. And as far as latency goes, Kong added a little bit more latency than NGINX. Now, in here you can see that it says NGINX controller. It's important to note that even though we deployed this environment, we deployed the NGINX environment using NGINX controller, the whole setup is replicable using NGINX open source for the left side graphs. You could set up basically the NGINX controller using NGINX open source. Not for JOT. For JOT, you'd have to use NGINX Plus because it's offered only in NGINX Plus. But I'm just saying that open source is open source. We are still faster, basically. This is just an overview of Kong's architecture. Probably part of why it's a little bit slower than NGINX. It uses NGINX at this base, but it uses OpenResty, which is an extension of NGINX, and it has many other components to it, such as clustering and data store, and then additional plugins that you put on top, and then there's the RESTful API that runs on top of all of that. Then the other tool we ran some performance benchmarks against is IBM API Connect, which is IBM's integrated API management offering. It manages everything related to your API gateways, and of course it's available on cloud, on premises, and hybrid deployments nowadays. The results we got were not that great. Should be noted, we run all these tests on the cloud using IBM's free offering, which makes me suspect they probably throttle a little bit of their connection, but it's important to note once again that using the left side graphs, it's also using NGINX free offering. So, it could be deployed using NGINX free offering. So if we're comparing pricing-wise, scenario-wise, one to the other, we still come up much faster. And even then, something like single request latency, the latency that's added using API Connect compared to NGINX is kind of insane. Once again, we tested NGINX using a 16-core 32GB RAM virtual server on IBM Cloud, and tried to deploy it on IBM Cloud to make results as close as possible within reason to IBM API Connect. Why such bad results for IBM API Connect? Well, if you look at their architecture diagram, it kind of should give you a little bit of an indication. It's a legacy application still to this day. You require multiple servers for multiple appliances to be deployed and integrated between each other. This, of course, when new request comes in to the IBM API Connect platform, introduces a significant delay. Then the third tool we compared against is Apigee, which is Google's platform for API management. Not built by Google, it was acquired by Google in this case, but it's still very popular, it's very well supported. It has great documentation, which, by the way, IBM doesn't really have. But the results we got, once again, very similar to IBM results. Once again, we're comparing Apigee to your SaaS platform free offering. So I think, honestly, that it probably, which makes sense because it's a free offering, they're introducing some throttling for security reasons. But once again, as always, if you look at the two left side graphs, you can also get these graphs using NGINX open source. So apples to apples, we're still faster. And once again, the latency that you had if you're using Apigee, there's a much bigger increase in latency compared to NGINX. Similar to what we do with IBM API Connect, worth noting that the virtual server we were using to test NGINX is a 16 core 32 gigabyte RAM virtual server running on Google Cloud, because Apigee is Google's platform. It also runs on Google Cloud. It's the closest we could get to it. Yes. Yes, correct. Why add so much latency? Well, if you look at Apigee's architecture diagram, once again, it has a lot of tools and individual components. There's the router and message processor, there's Cassandra, which is used to route requests. Then they have their own UI platform that also is integrated with SQL. All in all, I did some calculations. It was like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 components with NGINX controller. Basically, this 11 components shrink down to 3 components, which is your Postgres database for storing NGINX controller configurations, your NGINX controller GUI, and then everything else just handled by NGINX natively. The router, message processor, the Cassandra functionality, it's all included within NGINX, or handled by NGINX. So now for the last part of the usual Great British Baking Show, which is the showstopper, which is where I want to talk about NGINX controller and why you should use NGINX controller as your API management tool. Basically, we're faster than many other tools. And why is that? Because our control plane and data plane are totally separate. Other tools, such as Apigee, for example, or IBM API Connect, a new request comes through, it goes through the control plane, and then the control plane handles that request to the data plane, and then you get back the request, and then the response, you have to send it back through the data plane and back to the control plane to get it to the client that has sent the request. Using NGINX controller and your API management module, your control plane NGINX controller is totally independent from your data plane, which is the instance where you're running NGINX Plus. This means that basically your control plane, you just set up your API gateway, you publish it, and that's it. Once a new request comes in, it will go to your NGINX instance, which will handle all the routing, all the security policies, everything will be handled by NGINX natively. Which, in the end, since you're eliminating the control plane out of the equation now, makes your requests go through much, much faster. It's just a brief overview of what we support now with NGINX controller and the API management module. You can define and publicize your own APIs. We support all sorts of native security policies. Define how you want your traffic management to work. And we also include very good monitoring capabilities and alerting capabilities. And in the future, we'll have a dev portal and better analytics to assess your APIs. And finally, we are so much cheaper than all the other competitor tools out there. I stole this slide from Karthik's presentation yesterday, but basically we only charge based on successful API calls processed, which is huge benefit for if you're using an API management tool, because if you compare it to any other tool where you're just charged by API call volumes, if you get a DDoS attack or something come Black Friday or just a huge spike of traffic and trying to take down your service, you're still going to be charged for all of it. In our case, no, we won't charge you for any of that. And that is it. That was a very quick talk. But since it's also late on a Tuesday and it was a great British baking show based inspired talk, I brought in some cookies and some sweets at the end of and some macaroons at the end of the conference hall for you to enjoy and take home and savor your rewards.
I got a question on the different vendors that you chose to
Yeah.
bake up against. And I'm curious, for example, if you try to look at MuleSoft and Layer 7, for example, those are two I'm curious about. Like, were there difficulties in comparing those?
No, the sort of three we chose just based on the demand that we get on incoming customer requests and customer questions.
We chose traditional API management that I want to connect, something like cloud color, but in this case, two traditional ones. IBM API Connect was Apigee, and then something relatively new like those we covered last week. Newer vendors are able to do this.
But needless to say, we'd probably run some performance tests against all the other tools out there. There's no ATA, but it'll happen.
Anybody else have a question or the microphone?
Well, if that's that, then please grab some sweets and enjoy tea. Happy hour.